we all want quality, we all think we deliver quality, but of course there's this big, great question of what is it, and can we all agree on it? And we tend to think that it's gold plating, and we're going to find out that from an engineering and management kind of perspective, that that's not actually at all what quality is. We're going to get into how we use statistics to improve quality by looking at another area that has a lot of misnomers and a lot of misconceptions, and that is the production of concrete. To get there, because you're not all concrete materials engineers, we need to talk about what exactly concrete is and what it isn't, as well as we do that, introduce some of the areas where we have significant variability that comes along from the standpoint of natural variability, as well as variability that's really associated with man-made causes. And that's, in a paradigm, is going to actually be pretty important for us as we not only talk about statistical quality improvement, but when we get into the next module, which will be analysis of variance, that'll come back as a pretty strong, important component as well. So let's talk a little bit about what concrete is, and that's going to lead us to a little bit of what it's not. And an important aspect about concrete is that it has 4 primary ingredients, and really it needs 2 at the very heart of it, and that is cement and water. Now, people on the street, so to speak, pardon the pun, will say, "Oh, I skinned my knee on the cement." The reality is that no, you did not. You skinned your knee on concrete. You cannot skin your knee on cement, and that's because cement is a powder. When we say cement, we almost are always talking about Portland cement, and Portland cement concrete is the combination of cement and water that then it also has a whole bunch of what we call aggregate, as well as these days almost always some set of what we call admixtures. The cement is essentially like a flour. The approximate analogy you can make is making a cake here. And if I had anything better than my horrible high school French accent here, I would go into my French chef. I could probably do a Swedish chef better than cement or a French chef here. And so the cement is a lot like flour, and in many ways does the same thing as in its combination with water. But it's only an approximate analogy here. What really is happening is that through what's called the hydration process, the cement and the water react in an exothermic reaction, generating quite a bit of heat, which as a part of production of concrete is important, particularly when we get to the construction site, and if we're dealing with mass concrete, that's a very important issue. And if you ever seen videos about the construction of Hoover Dam, that's one of those mass concrete projects where they had to construct the dam in a very special way to deal with the heat that was generated from the exothermal reaction between the cement and the water. And again, the cement here is the sort of flour that's providing a lot of stabilization here. But a little bit unlike the cake analogy, we put a whole lot of aggregate, which are just a general term for the sand and gravel that we put in there, that although it has some other properties for us in terms of stabilizing the mix and also providing some strength to the final product, it really, at the end of the day, is inexpensive filler, or what I like to say, it's dirt cheap. Yes, that was a bad pun. A lot of people will call sand and gravel dirt. It's only dirt when it shows up on your parents' kitchen floor and it's tracked in, but out there in the world, this is aggregate, and it's not dirt. Dirt's a 4-letter word, and sand, yeah, I know, it's a 4-letter word too, but it's a good 4-letter word, and particularly because it's inexpensive filler, because cement, Portland cement, is quite expensive to both produce and to provide then into this particular mixture. The cement and the water are going to combine to make concrete that is holding all this other stuff together. Now the admixtures here are essentially your spice that you add to your cake. We do all kinds of different things. It might be a coloring admixture. There are all other kinds of admixtures that are there to speed up, say, the chemical reaction, speed up the strength gain, There are also sometimes in there they're called super plasticizers that help to make all of this conglomeration, instead of like a thick viscous peanut butter when it gets delivered to the site, it's a lot thinner, and being thinner means that it is easier to work with. But there's a sacrifice that comes at the cost of oftentimes the making something thinner, and certain super plasticizers can do that without having that disbenefit that we'll talk about here in just a moment. Right, so important for you to not sound like just a common garden variety person on the street. When you walk across, roll across, live in structures that are supported by concrete, you can hurt yourself on concrete, absolutely, but you can't skin your knee on cement. You can only skin your knee on the concrete. It gets delivered to the work site, by the way, of course, in a concrete truck, right? Not a cement truck, but a concrete, and sometimes they call it a mixer truck. This one has rear discharge. Some of them have front discharges over the cab, and this is a rotating drum to keep that moving around. That's really not where we produce the concrete, although it is possible to actually do that, to do a dry mix, add the water, and do the mixing in there, right? And some of the crucial factors, and they relate directly to the so-called quality of the concrete, that the influential factors in the compression strength, the most dominant and primary one is that ratio between the water and cement. Now, these days there's supplementary cementitious materials other than Portland cement that we might use there, and so if you're really deep into this stuff, technically we talk about the water to cementitious materials ratio, but it's the same idea here. Water to cement ratio, based typically upon on weight, and the yin yang that happens here is that the construction industry wants the water cement ratio to increase, because with it you get a thinner, more fluid like mix, and so therefore you increase your workability. Unfortunately, you significantly decrease the strength, as well as a lot of other both mechanical and physical properties that are of desire from the engineering standpoint. And so because of that, your theoretical perfect water to cement ratio for a lot of applications is about 0.33. Unfortunately, that has very difficult workability constraints, and so more practically you might be on the order of 0.4 to 0.45, and maybe on upwards of even 0.5, without regard to what happens with admixtures. And certain admixtures, what happens is that you can pull your water cement ratio down to 0.33, but have the workability that's closer to 0.45 to 0.5. And what that means is, from a practical standpoint, is that your typical fluidity that you have on the job site is such that your typical construction worker will talk about pouring the concrete. And classically, we don't like that as engineers at all, because if your concrete is so thin that you can pour it, that usually means you have way too much water and subsequent problems with the strength as a result. It's a classic case where the workers will have the concrete delivered to the site. They will see it as being too thick and not workable, so they'll add water to it to make that, as it comes out of the chute, they'll add water, and that just destroys the quality of your concrete as a result. So you try to be eagle-eyed on the inspection, make sure they don't do that sort of thing. Okay, the other influential factors here are that the aggregates properties are such that you are very interested in what their absorption is of water and what the water content is during the production process. That you have two kinds of things. If you had a bone dry aggregate that you threw in, well, some of that mixed water that you're going to throw in is going to get absorbed into the aggregate pores, and that means that that's water that's not available for your hydration, and you can get too little water available, and not only do you have workability problems, you won't have complete hydration, and that becomes an issue. The other part of that, though, is that your water content from a day-to-day standpoint will be variable within that aggregate pile. If you have high humidity and dew that forms overnight, you're going to change the water content of the surface of the aggregate, just the same as if you have a storm in one day, and that will change the water content. Certain batch plants will have ways that they try to accommodate for that by either measuring the water content as the aggregate then comes into the mixing process and adjusting in the mixed water accordingly, or they'll have dryers to try to alter things. It's another aspect of concrete production that you monitor the temperature of the aggregate as well. That's related to whether it's a cold day, hot day. All those sorts of things are going to affect what happens, particularly with the mixed water, which is the real key in trying to control that. From a time element standpoint, another huge important aspect is that the properties of concrete are just like a cake, that they change in time. And the slightly different aspect of that here is that we're talking about a time scale of days, and really eventually and ultimately years, that if there's sufficient water around, the compressive strength of the concrete, that I'll label as F sub C, is going to be a function of time, and it will continually increase if there's sufficient water around. And it increases quite rapidly at the beginning and then will eventually level off. But even though the characteristic important time frame is usually the 28-day, you can get about an additional 10% strength increase over, say, 28 years from this standpoint. So it will continue to gain strength, and from a evaluation of existing structure standpoint, that is an important aspect to take note of. Right? From a design standpoint, this 28-day strength is a common target value that we're using, and somewhat just made up notation, I'm going to call that F sub 28 to notate that. The 7-day time frame is also a typical important time frame, and that 7-day strength will be somewhere around that 0.7 to 0.9 of the 28-day. That's not a minus sign, that's just a dash to indicate the range. It's more commonly, in my experience, been around 0.9, 90% of that. And again, the whole critical issue here is that you can monitor, measure quality, try to predict what's going to happen in the long term by measuring something in the short term. But 28 days is our key design value, and it's very important to understand that the strength and quality of concrete is a function of time as a critical influential factor. And then one more before we get back to a larger question of what is quality and statistical quality control and the techniques that we're going to work with here in this course, is that the curing process is also one more important aspect. Right now, go back into our cake analogy. The temperature at which you bake the cake is going to have a significant influence on what happens to that cake. The rising of it and the pores that are created as the gluten reacts and creates the sponge-like texture in the cake. Well, curing process is sort of like the cooking process, although we don't cook the concrete. It creates its own heat all by itself. The curing process is really all about maintaining hydration or maintaining available water. And so what you'll see in particularly these specimens that we're going to pull out for our sampling is that we'll actually keep them submerged in a tank of water, and that way they for sure have available water to continue on. Now that in itself is going to be important, because how we do the test is not necessarily reflective of what happens out in the construction. So the testing itself is going to be only a potential representative of what's going on out in the field. But out in the field we have all kinds of curing methods that are out there, and they include setting up misting operations or fogging operations, where we spray water over the concrete as it goes through this process. of gaining strength over time. Sometimes you put wet burlap down, other times there's visqueen or plastic barriers that are put down. But this maintaining the water is very important in this curing process. Once you set up and the concrete begins to harden, then you add water, and you're not going to create problems with the water cement ratio. You're just providing enough water so that you don't have the surface dry out and consequent scaling and other quality issues that result. And so a bigger question here then exactly what is quality and how can we measure it, and coming up with some sort of more definitive way to measure it. And the one aspect of this is that when you start getting into the details of each field, there's going to be different specific measures of it, but there are some generalities that we can find that goes beyond just even the manufacturing area and also into the service industry, and whether that's management services, banking services, or whether we're talking about a specific manufacturing process. There's some generalities here. And one crucial idea is that fitness for purpose is what we're really talking about when we mention quality. This is not about gold plating. And so a lot of times your typical person thinks that this is just unnecessary kinds of things that are happening. It's just somebody wants to live in a gold paradise, or they want in their high definition entertainment system, they're going to go get the gold plated HDMI connectors, and because they've been told that that's better, right? There's a marketing thing there. Well, it actually turns out that in that specific case, the gold plating does actually have a benefit in terms of the engineering function, right? And so that's an important aspect about this fitness for purpose, is that we're trying to meet functional requirements, right? And so, yeah, then in some instances, gold plating does bring with us higher quality, but this is not necessarily the difference between giving someone a zirconium engagement ring versus a diamond engagement ring. This is about specific, actual, real functional requirements, and also a notion of quality is somehow the notion of freedom of defects. And so we can talk about lower and higher quality being maybe not free of defects, but the number of defects or the rate of defects is some aspect of quality. Now, two other ways we can begin to break down quality are between quality of design and quality of conformance. And by quality of design, it really relates to this first aspect here about meeting functional requirements. And so we're going to, as we're going to take a marketing idea, a market analysis of a potential product, and translate that into tangible then engineering guidelines and designs, then we think about different grades or levels of performance, and in particular we start getting into also reliability and serviceability, which in my world relates to things such as if I walk across a floor and I create a lot of vibrations, and so much so that even though there's plenty of strength, you end up with creating irritation amongst other participants or users of the facility, then those vibrations then become a serviceability problem. And if you have a building that has enough strength but can't be leased because of excessive vibrations, then you have just as much of a failure as if you had some sort of a collapse or partial collapse, right? And so different grades, levels of performance, reliability, serviceability, and function. For example, we might be talking about the necessary compression strength, might be talking about durability, ways we quantify that, might be talking about physical properties such as density. Each one of these is coming right out of the concrete world, but it is more general as well to all kinds of materials. And really ultimately all of these are things that we make deliberate engineering and management decisions about. And now another aspect here is of quality is this notion of quality of conformance. And one really crucial aspect about quality improvement is the systematic reduction of variability. Now again, in my world as a structural engineer, I'm usually designing one-of-a-kind kinds of structures. But when I select a steel member or I'm ordering up a certain concrete, I'm expecting that the producer is going to be able to provide that product with a certain reliable set of material and mechanical properties, right? And so that reduction of variability goes to the consistency of the product. And so something that's of higher quality you would associate with less variability, right? And also we would associate a reduction or even elimination of defects. Now we're going to get in more precisely later on about a specific definition of what is a defect, but so we'll just kind of leave that hanging out there for a moment. Right, now quality improvement as a whole then is about the reduction of waste, and that might be in terms of both reduction of material as well as time. I really like to think about this as reduction of waste of resources, and resources are more than just tangible things, but time is certainly a resource. And reduction of variability sort of goes hand in hand with this, that something that's less variable, then we can be more efficient, and if we're more efficient, then we are reducing waste. And so then finally, for where we're at in this particular module is to start thinking about statistical quality control, which is really the use of statistical tools to identify and ultimately reduce variability, at least those aspects of variability that we can reduce. And so broadly speaking, there's really sort of two different causes of variability. There's chance causes, and there's assignable causes. And in another segment here, we'll get into more detail about what exactly chance causes or assignable causes are. But that's going to be a particularly important aspect about variability and process control, and also thinking about product control, and as well when we get into analysis of variance, that will also, this division of things will come back to play as well.